With over 12 million organic compounds in the world, the job of naming them is a difficult one. Chemists would discover or synthesize new compounds and give them names, but very soon this became quite confusing. The International Union of Pure and Applied Chemistry has solved this problem by developing a set of conventions that present a standard nomenclature for naming compounds. This is going to be the focus of this section. We're going to learn some of the rules that will allow us to give specific standardized names to organic compounds. Those names have become known by the acronym IUPAC. And so you'll be asked to determine the IUPAC name of a particular compound. We'll focus on learning the basic IUPAC rules and apply it to naming some of the simple compounds in our syllabus. Most compounds retain their more common name, and so for instance, this spectacular compound is called 1,3,7 trimethylpurine 2,6 dione, but mostly it's just known as caffeine. To understand the foundation of the IUPAC system of naming compounds, I think it's helpful to consider a little analogy. There are over 7 billion people in the world. How do we go about naming all of them? Well, if you think about it, we solve this problem by breaking everyone into family groups. Each family is then given a surname that identifies that particular family. So in your community, there may be a family called the Abrahams, another one may be called the Dlaminis, and possibly the Govenders. Now within the Abrahams family, the individual members would each have a unique first name. So they might be Patrick and Hannah, they might both belong to the Abrahams family, and each of them are then separately defined by their individual first names. It's not a perfect analogy, but it's a good starting point for understanding the IUPAC system. Organic compounds are also divided up into different families. We call them homologous series. Each family's got a particular surname or suffix. And so for example, the alkanes all end in the suffix -ane, and the ketones all end in -anone. The individual members of a homologous series are then defined by the number of carbon atoms in the chain, and that determines the prefix. This is like their first name. So if there are 2 atoms in the chain, then the prefix is F, and if there are 8, then the prefix is oct. Let's look at the list of prefixes and suffixes that you're required to know for your syllabus. Remember, the prefix specifies the number of carbon atoms in the main chain. If there's just 1 carbon atom, then the prefix is meth. 2 is eth, 3 is prop, 4 is bute, 5 is pent. If there's 6 carbon atoms, then it's hex. 7 gives us the prefix hept, and 8 is oct. You're just required to know those first 8. Now I think from pent onwards, they're relatively easy to remember because they link in with your math syllabus. But for me, those first 4 are difficult to remember. And so I make up a little rhyme with the first letters of each of them, M, E, P, and B. When I was at school, our teacher gave us this little rhyme, Mommy eats peanut butter. If you don't like that one, make up your own one. Anyone that gives us M, E, P, and B for meth, eth, prop, and bute. The suffix then indicates the homologous series to which that compound belongs. I'm afraid there's no way around simply learning these off by heart. Let's have a look at them in turn. The alkanes are characterized by a carbon-carbon single bond, and their suffix is -ane. The alkenes have got a carbon-carbon double bond, and they end in -ene. And the alkynes have a carbon-carbon triple bond, and their suffix is -ine. If we then move on to the alcohols have got that OH hydroxy group bonded to a carbon atom, and their suffix is -anol. The aldehydes have got the carbon-oxygen carboxyl group on the end of a chain, and their suffix is -anol. Ketones, we have the carboxyl group somewhere in the middle of the chain, and their suffix is -anone. Carboxylic acids have got the C double bond O and the COH at the end of a chain, and their suffix is -anoic acid. And esters have got a carboxyl group and another oxygen bonded in a chain of carbons, and their suffix is -anoate. So then at its simplest, the IUPAC system names organic compounds according to the homologous series it belongs to that's like your surname, and then according to the length of the carbon chain, that's like your first name. All right, let's try some examples. If we're naming this compound, you can see that there are 5 carbon atoms, and so the prefix then is pent. And then we see that there are only single carbon-carbon bonds, which means it belongs to the alkane homologous series, and so the suffix is ane. So the name of that compound would be pentane. Moving on to this one, we start by having a look at the length of the carbon chain. We're numbering from right to left because that carbon holds the functional group. We see there are 3 carbons, and so the prefix for 3 is prop. We then identify the homologous series. There's the functional group, and that homologous series is a carboxylic acid, and so the suffix is anoic acid, and the name of that compound then is propanoic acid. And then finally this compound, again we number the carbon chain from right to left because that carbon holds the hydroxy functional group. There are 2 carbon atoms, and so the prefix is eth. That OH functional group means it belongs to the alcohol homologous series, and so the suffix is enol, and so the name of this compound is ethanol. Naming organic compounds is obviously a little more complicated than this, particularly when we start adding substituents to the chain. But don't worry, we'll get into that when we look at each homologous series in turn. For now, you need to spend a little bit of time memorizing those prefixes and suffixes so that as we start to name, you become comfortable with those.